Let her speak.
What are the molecules doing? Is there a difference in what the molecules are doing? Chemical changes? And eyes tracking me in 3, 2, 1. What were we sharing with our partners? Do
We were sharing the differences between physical and chemical changes.
And what do we come up with? What do we think?
Like physical, it's like a tree getting chopped down, and then a chemical, it's like a tree getting burned.
So in those examples that you just provided, what are the molecules doing then?
Staying the same when you're on the, they're staying the same when you're breaking down the tree.
So when you're cutting down the tree, do we saying the molecules that make up the tree are still the tree, the same molecules, they're just taking a different form. But when you burn the tree, all of a sudden what's happening to those molecules of the tree? Are they still the same? What? The molecules are changing during that? Shay?
Like, those changes, like, you change back, and that makes sense.
Sure, yes. Think back to the water example. You can freeze the water, you can unfreeze it, you can freeze it back again. Yes? Now think back to our lesson from Friday. When there's a chemical reaction occurring, what are some signs that are given off by a chemical reaction that let us know that a chemical change is actually taking place? What are some signs? Well, think back to like the food. Think back to food. We can use our senses to observe some of these. What are some signs that would let us know, give us an idea that something else is going on here? There's a chemical change occurring. Marina? Yes. So, if we're using our 5 senses to determine whether a change is taking place, right, we're using our senses, what's something that we would observe then? Yes. And what would we see that would let us know a chemical change is taking place? Think to bread. What happens to bread when you leave it out? It molds, it rots. And what are you seeing with your eyes? How do you know that it molds? So, color change, yes? You can look back to your notes from Friday here. You're looking at the signs of the chemical reaction. So color change is one. Yes. Ricardo, can you give us another?
Touch or
It might feel different. It might. Sure. It might feel different. Talia? What are some signs that a chemical change is taking place? We've said color change. We said the texture might be different now.
Like sometimes it's like when the
Odor, there's some odor given off, yes, absolutely. Kevin? Huh?
Temperature?
Temperature changes, yes. Kalia?
I need taste.
Well, I don't know if you want to be tasting a chemical reaction, but sure, I think spoiled milk would taste differently than regular milk.
But
But I wouldn't try
I've
that.
eaten a lot of
It's
corn
kinda
without
mushy.
noticing, and then all of a sudden it's
Okay. Signs of chemical change.
Why is it so bad?
You know what's a really great way to learn about science? Baking. After all, baking is pretty much just chemistry. And chemistry is the science of different kinds of matter and how that matter can change. Sure, some of the equipment used in baking and in chemistry isn't quite the same. But both baking and chemistry require careful timing and measuring, and both of them result in the formation of a mixture. For example, you can change matter like eggs, milk, flour, and sugar into a tasty dessert. Now, you already know that a mixture is anything made by combining two or more different things. And some kinds of mixtures, like the fruit salad we had at our picnic, can be separated back into the substances that made them. But that's not true about all mixtures. Sometimes mixing things together makes a whole new substance. We call this a chemical change. But what is a chemical change? A chemical change is a change that occurs when the particles that make up two or more substances are rearranged to form a new substance. Unlike the mixtures from our picnic, chemical changes usually can't be undone. Let's observe an example of a chemical change. Observe, people. We're not trying this at home. When we observe a lit match, we see that the match burns. As it burns, it changes into burned wood and ash. We can't change this ash back into a match, so burning is an example of a chemical change that can't be undone. But wait, there's more. Chemical changes often make matter change color, like the blackened remains of the match. Sometimes chemical changes make smells or release light or gases, and lots of chemical changes require either the giving off or taking in of heat. A burning match gives off light, smoke, and heat. All of these things are evidence that when we look at a burning match, we're looking at a chemical change. Now we can do a simple investigation to show how some chemical changes can yield a seriously yummy results. When we mix the ingredients of a cake, we're mixing together different kinds of matter. Say you have flour, sugar, milk, and eggs. When you put them in a bowl and stir, you're mixing several different substances together to make cake batter. And when you pop this mixture into the oven, after a short time, you have a new substance, cake. Now, before you eat it, let's check this science cake for evidence of a chemical change. Did the reaction give off or take heat? Definitely. The cake batter needed the heat from the oven to change into cake. If we left the batter on the counter, it would stay batter. Is there a color change? Check. The batter in the pan was yellow, and now it's a nice golden brown. Is there any smell? Well, if you've never been in a bakery or some grandma's kitchen, or just never smelled a cake baking, then I feel bad for you, because it smells amazing. Were any gases released? Let's look at our cake before and after. Before, we have a wet, gooey batter. After, we have a nice, fluffy cake. As the cake was in the oven, some of its ingredients released carbon dioxide gas. We can see evidence of carbon dioxide when we cut the finished product. All those little holes in the spongy-looking cake are caused by this gas. Our last piece of evidence that we've witnessed a chemical change. This change can't be undone. For example, we can't get the water we put into the batter back out of this cake. Even if we were to squeeze it really hard, we'd get crumbs. So let's not try. So, a chemical change is a change that occurs when the particles that make up two or more substances are rearranged to form a new substance. Most of the time, chemical changes can't be undone, and you can tell they're occurring by observing them and noting things like changes in color, release of smell or light, and whether they take in or give off heat. All in all, I see that sniffing out chemical changes can be a piece of cake.
Questions, John?
I was saying that I noticed that the chemical changes can't be undone.
Again, back to fry, perfect, yes. Chemical changes we know cannot be undone. Once they happen, we can't go back. Once the food spoils, we cannot bring it back to its original state. Once that iron rusts, you can't take the rust away. So we've already created that new compound. See?
Wait, kind of confused. When you get out of a tree, is that a physical change?
That is a physical
Or you
change.
can't do that?
Well, you can't put the tree back together, but
Like, I'm confused on that.
But when you cut the tree, the molecules in the tree are not changing. So that tree, it's still a tree, it's just cut in half, it's just on the ground now. It looks different. It's not standing up anymore, but the tree that's down is still a tree. Right? Once you take full of milk, you've got full of milk. You don't have regular milk anymore. You have a cut down tree, you still have a tree, it's just cut down now. Does that make sense?
I'm just confused.
So color changes. When it comes to cooking, sugar. Don't worry about the term, it's called the Maillard reaction, but sugar lets us know that it's going through a chemical change when it turns to different colors. A lot of the foods we eat contain sugar. So when we cook food, when we're cooking food, we see it turn like this brownish color. We make toast, we see it turn a different color. It's a sign of chemical change. So with physical changes, again, no changes in the molecules. A new substance is not formed. But you named off some of these examples earlier. We'll see changes in size, shape, how they feel. Doesn't necessarily mean a chemical change has occurred. With a chemical change, you're getting a new substance, and the substance is letting you know that something's going on because it's either giving off heat, it's giving off a scent, it's giving off a different color change. Those are all evidences of chemical changes. So, in our notes, let's take a minute or two. An example of a physical change in our own words. I'll give you 2 minutes to write. An example of a physical change in our own words, and then some examples of what a physical change might be. We'll come back and share whole group. I'll give you 2 minutes to write. Sorry. You're right. Yes. Sure. I'll just start with make sure that you're doing the examples. A little under a minute. Eyes track of these, 3, 2, and 1. Would you like to share an example that they wrote down? An example of physical change. Dewey?
Oh, okay. Mm, pencil breaking.
Pencil breaking. Does everybody agree that pencil breaking is an example of physical change? Why is that an example of physical change and not a chemical change? Why is a pencil breaking an example of physical change but not a chemical change? David?
Because they're not the same, they don't change, or they're not mixed.
Yes, because it's still a pencil. The molecules haven't changed. The broken pencil, while it's broken, it's still a pencil. Great. What about, I'm sorry, do we have another example? Yes, a pencil breaking is an example of physical change. See?
The tree getting cut down.
Tree getting cut down. Yes, similar to the pencil breaking, physical change. So what are we noticing about the pencil breaking, the tree getting cut down? How do we know that physical change has occurred then? April? Sorry, Tara?
The physical change, you could tell since if it's not a chemical change, because a physical change, the molecules and the chemicals are all the same. They say the same, and physical changes can be, it's just a pencil. It is the pencil that's changing.
Yes. So then what we've been discussing, I think what we've been repeating a lot is that molecules during physical change are not changing. And molecules during the chemical change, they change to create a new substance. And when a chemical change does occur and a new substance is created, there are signs. These signs included odor, color change, temperature, Julie, question?
Last time when we were doing this, I don't know what day it was, but it was the Princeton International and you put bubbles.
Bubbles? Those were just like stuff that we were discussing in the class. So. Bubbling and fizzing. When the physical changes, again, think back to the pencil and the tree we just stated. What do we see? What do we see with our eyes? We see that the pencil clearly just got cut in half. That the tree just got cut in half, so it'll be a size change. One full tree compared to a half tree, so mass will change. at this point, I'll give you 2 more minutes to finish taking down these notes on your paper, and then we'll work on our exit ticket to end our class. Since we're still writing, if you've taken down all your notes, now would be an excellent time to really test yourselves and maybe include some illustrations on your notes regarding a physical change and a chemical change. You might try to jot something down. A picture that would have something to do with a physical change, such as the tree being chopped, or you getting a haircut, or something like that. If you cannot draw, then it's okay to include written examples. For example, a physical change includes X, Y, and Z. A chemical change, a chemical change I've observed when this has happened. Give you 30 more seconds to write. Eyes tracking me in 3, 2, and 1. Pencils down. Wait for the pencils down and eyes on me. Okay. So at this point, you can now take your science journal. You may use your notes. But what I want directly in front of you is your exit ticket. Your exit ticket was on the back of your do now. So take your do now, flip it to the back side, and go to your exit ticket. You'll be called ready once I know you're ready. Thank you, Marina. Thank you, Javier. Sarah, Adriana. Okay. So you have 5 minutes to work on the exit ticket. Sign it in independently. We'll check back in 5 and see what we got. 5 minutes. You may begin. You may use your notes. Zaya and Monse have got about a sentence or two completed for the first part. claim, the evidence, and the reasoning portion. Your claim is just what you think the answer is to the question. Your evidence is when you describe why it is that you are making that claim. You're supporting your claim. And your reasoning is when you bring it all back together. Which one?
Yes. Oh.
A little over a minute left. Anything else? Conservation maps. Now need eyes tracking me and pencils down in 3. Finishing off our last thoughts. We got to the claim, evidence, reasoning. 2. And pencils down and eyes on me in 1. Pencils down. Okay, let's run through it very quickly. Number 1, who would like to share? Tony?
I put chemical changes and physical changes are different because chemical changes can't go back with, while physical changes can.
So, awesome. So Tony's saying one main difference between chemical and physical changes, chemical changes you cannot go back. Physical changes, such as when ice melts and becomes water, you can freeze that ice again and make it ice. Or when you take water, you freeze it, it can go back to just being water after you leave it out. So it can go back. Chemical change, once that happens, you can't go back. Adriana?
I said one difference between chemical changes and physical changes is that the chemical changes the molecules change the chemicals, and the physical change is not different.
So Adriana saying yes. During a chemical change, the molecules are changing. During a physical change, the molecules are not changing. That broken pencil is still a broken pencil. Number 2, which of the following situations provides evidence that a chemical change is taking place? This one's tricky. This one's tricky because there's one in there that you might think is a chemical change, but it's not. Julia. Number 2, what do we get? A, B, C, or D? Which one do you think? D? Sugar when added to the iced tea dissolves into a liquid. Somebody get a different answer? Davey?
I'll go C, because it was mixed until it was